So what is a constructor? A constructor is a function that is named after the class, and the function constructs or instantiates the object. So when we have a class foo here, and we want to instantiate ourselves an object from that class in our program, we can use any one of these three constructors in order to do so. If you look over here to the right, this is how we would use those. Now keep in mind these are prototypes, and these are the call to the implementation. We don't see the implementation here, we just see the prototypes. So here on the right we see the call, so we are creating we create a foo object, and it is going to automatically call this first constructor. You can tell because we are not passing it any arguments. And the same thing here, we are defining ourselves a pointer on the stack and returning it an address on the heap, and we are not passing any arguments, so we know that the constructor is a default constructor, or this constructor right here. We call this a default constructor, and we will get into that in more detail in just a moment. Here we have another constructor, b, and it takes one parameter. So we've created ourselves an object, a foo object. We name it 3 or f3, and we pass in 5. Now this constructor is not 100% clear, but my guess is it would be some kind of conversion constructor, since foo is not an integer and we're passing it an integer, meaning a conversion constructor is a constructor that changes whatever you are passing into that object into an object of that type. So you see we are doing the same thing here with this object on the on the heap. And then finally we have this third one, this blue one here. It's an object. It's a general constructor. And the way we know that a constructor is a general constructor is that it has more than one argument, or it isn't any of the other constructors. So, and you can see that we are passing in a 5 and a 10 to an object here, and so this is how we know that it is a general constructor. Here is the default constructor. So this is a default constructor. It's automatically created by the compiler. It's so important that if you don't create one, that your compiler will create one for you. So this is a couple of examples of our old time class that we created, our old time struct converted into a time class constructors or initializer lists here. So let's go over these. So we have we are instantiating each of our member variables, hours, minutes, and seconds, to equal 0. So we're initializing. We are giving these member variables a value so that when the user tries to access or use these variables, they don't reach uninitialized space, which can cause big problems. So here we have in B, we have our time constructor. So see, we have time and then our parentheses indicating it's a constructor, no return type indicating that it is a constructor. And then we have this semicolon here, and this comma separated list with our variables, our member variables, hours, minutes, and seconds, 0, 0, 0. So they're all being initialized to 0 here. So here we are creating a default constructor just by using our initializer list. Now check this out here at the end. We have parentheses. Remember, whenever you're creating an initializer list, to put those those curly braces, because if you don't, you are not completing your function. Every initializer list must be with a function, a complete function. So you can't just throw a semicolon at the end and call it good. You have to put these brackets in, or these curly braces. Moving forward, we have here our specification of our class time. And here, this did not used to be the case. You did not used to be able to do this, but now you can. You can initialize your variables right when you are defining them in the class. So that is a new addition, but it is very convenient. So a conversion constructor converts some data type into an instance of a class. And it has one argument. So I talked about a conversion constructor earlier. I'll point that out to you. It was this one right here. Right? So it has one argument. So notice here we have our member variables defined in our class, specified in our class. And then we have a constructor. We know it's a constructor because it has no return type, and we're passing in one variable of a different data type. Then we do some sort of operation. We implement some sort of operations in order to convert whatever it is that you're passing into that function into whatever it is that you are trying, whatever it is your class is. So right here, we're passing in a number of seconds, and we are converting that into hours, minutes, and seconds, which is really the substance of our class time. Here are some examples of conversion constructors. So here in example 1, we have class foo. We have class foo. The particulars in this case are not important. Let's pay attention to just the call here. So we have a constructor, as again I will repeat, we know this because there is no return type and it is named after the class, so we know that that's a constructor. And we're passing in a parameter that is of type bar, and we are calling it B. We're saying that parameter is called B, so when we use it, we'd use B to reference it. So this conversion constructor would convert a bar into a foo. Example 2 here, we have a string. So we've seen the string class now, and we're calling it S, and we're using these parentheses to pass in a C string or a char array that is containing the words hello world. And that string class is going to convert that hello world C string into a string object. Let's talk about the copy constructor. It creates a new object by copying an existing object. If the programmer does not define one, the compiler will generate one also. This is one that the compiler also generates, and it does so because of 3 fundamental operations that the compiler relies on for it. So the assignment operation relies on a copy constructor. So when you're assigning your value, your class, to another class of that same type, so you say you have a person, P1, and you're assigning a P2 person to that P1, that is how we're going to use the assignment operator. So your copy constructor uses the assignment operator for that. It also uses pass by value. So when we are passing an object into a function, we will use that assignment operator to do so. And it's the same with the return by value. So we know it's returned by copy from earlier discussions. We know that it returns a copy using that copy constructor. So it is vital that your compiler has one. So it'll create one if you do not. However, you can create them to be specific. The way you know it is a copy constructor is it has a very specific signature, and you have to do this whenever you create a copy constructor. It takes a single argument, and that argument has to be the same class type as the class in which the constructor appears. So if you're creating a person class, you would have to pass in a reference to that person. So that was my next caveat, is it always has to be a reference to that variable. So pretend this is a person, so it'd be person, and you would pass in a person reference P. This is just some generic class name. So that is a copy constructor. This is a very specific signature. Just remember that ampersand, that one ampersand, goes along with the copy constructor. Here, we're going to talk a little bit about the move constructor. So it can be identified by its distinctive arguments. Notice here, it is very similar to the copy constructor, except that it has 2 ampersand signs. If it needs more arguments, then those must be default arguments. So when creating this class, if you need to create it with more arguments, then you need to create it with those as default arguments. It takes the resources held by the argument object rather than copying them. So this is beyond the scope of our course, but just something to look into, something to study on your own time is the move constructor. Very interesting. And here we have the general constructor. It has no special syntax. Any constructor that does not fit into the previously talked about categories is a general constructor. And any constructor with 2 or more arguments is also a general constructor. Now, don't let this scope operator throw you off. This is just an implementation of a constructor outside of this class specification, so in the .cpp, the source file. And we use this scope operator to tie it to that time class header file. Notice here that there is no return type and that the function's name is named after the class. There are now 3 parameters, so we automatically know it's not a default constructor, a conversion, copy, or a move constructor because it has 3 arguments. And if it's not any of those 4, then we know that it is a general constructor. And we are going to set our member variables here inside this constructor. We're going to set them equal to whatever the user passes in. So we have hours, minutes, seconds. Those are class member variables. We're going to set whatever the user passes in equal to those variables. Therefore, setting that class's variables equal to whatever the user desires.